So for the musical instrument, or actually, the meeting with Stas yesterday, he gave me a great name idea for it. We're calling it Mind Synth.
My idea. That's what I call it.
Oh, it was yours? Huh?
In emails, I call it Mind Synth.
Oh, I'm using it.
Okay.
Anyway, this here is one of the two amplifiers we're working on. This is designed to actually link into the heart. The other one's going to link into the brain. It's going to be take a little bit more work than this one, which is based off of, it's basically just a design I've already built, or I'd already built, and in the past. And just a quick demo with the computer interface. So no, if you go ahead and look at the screen, every little vertical spike there is where my heart beats. Right now there's a lot of noise. I really haven't tuned the filters at all. There's still a lot of debugging to be done. Basically, every vertical spike is a heartbeat, and there are also smaller bumps that are different aspects of my heart. And basically what I'm going to do is I'm going to take this and use it as input to set up a backbeat for the Mind Synth. Very similar technology, except with just some different amplification and filtration tuning, is going to be used to connect to some electrodes on my head, which are going to pick up my brain waves. And we're still kind of looking at what we're going to do with it. Probably it's going to provide some sort of modulation for the synth.
That's awesome.
Cool, yeah.
Yeah. In the future, we're going to be able to get a lot cleaner signal. This right now is I honestly finished this like 5 minutes before I came over here. So this is it's a little noisy because it's very heavily amplified. The input, we have some input filters on it to prevent it. For some reason, without the input filtration, it tends to ramp up and hit the top rail. So I threw on some input filtration, but for some reason it's providing serious, it's seriously suppressing the signal. Don't know why. It usually doesn't do that.
Cool.
But yeah, so we're gonna have this one. We're gonna build another one to interface with the brain. We're gonna be writing software that's going to allow it to start making music.
Cool.
I got a question.
Yes.
Can you influence your brain waves, I guess, or is that something that sort of just happens?
Biofeedback. Well, you can use biofeedback, I believe. I'm not really that familiar with it, but watch this. So you can kind of see my heart rate here.
So you do jumping jacks and like increase your rhythm. All right, yeah.
It's high blood pressure.
I can follow that.
There are some artifacts.
You start jogging or something.
That's crazy.
It's not usually. No, wow. Okay. This is good. It's not picking up any of my muscle artifacts. I must have the electrodes positioned really good. Usually, whenever I move my arms, you can see some artifacts from the. It just goes all over the place. But you see, it's a reasonably good signal. If you look, you can kind of see some bumps before and afterward. Actually, my previous application of this amplifier was actually a medical device that could actually send it to a doctor. That looked way better than this. Once again, it's just thrown together today. Any questions on like maybe how it works, or this is yes.
How does it pick up the heartbeat?
Okay, well, whenever your muscles fire, they produce a tiny electrical current, somewhere on the order of maybe, I'm trying to remember, maybe like 10 millivolts. So what this is just an incredibly powerful amplifier coupled to a bandpass filter. And we also have a couple input filters. The amplifier is a differential amplifier, so that way if there's a difference in between, it only takes a difference between the two, so if there's like any common elements that are just completely, or are very nearly completely eliminated from the signal. One really neat thing is I kind of cheated on this. It requires a plus minus 2.5 volt supply. What I did was I took a 5 volt supply. I have a voltage divider hooked into an op-amp buffer. So I basically create a dummy ground voltage at 2.5 volts. So I have this entire thing set up thinking that the plus 2.5 out of the Arduino is basically halfway. So the Arduino ground is what this views as minus 2.5. Yeah, it's kind of a hack, but it's worked pretty well so far.
What's your power supply? Is it USB?
Yeah, it's pulling power from USB.
Okay.
So yeah, if something really goes wrong, so on a lot of phases, I might get zapped. Oh. Thank you. Not that handy.
No, it works.
But yeah, we have bandpass. We actually have two dual active low pass and high pass filters on this thing to get some really good really good bandpass attenuation. Yes.
What's the bandpass filter being used for?
Okay, so there's a lot of noise coming out of this thing because we're taking a 10 millivolt signal and amplifying it to I honestly don't remember what the figures were. I had all the math worked out back when I first built this, built the first model. But basically, there's going to be a lot of noise coming off of it. We're picking up 60 hertz noise from the power. Fluorescent lights are really bad about that. And sometimes we're picking up a lot of noise from that, and basically just it's a lot of noise from your muscles. So like when I move my arm, it generates a very high amplitude, but very low frequency electrical signal. And so that tunes. We have that the high pass filter tunes out a lot of the muscle noise, and the low pass filter tunes out ambient or just basically 60 hertz noise and higher frequency noise.
Cool. All right. Well, let's give David a hand.